Hello guys, so today we're going to be doing LeetCode question 133, clone graph. The question is, given a reference of a node in a connected undirected graph, return a deep copy, so a clone of the graph. Each node in the graph contains a value integer and the list node of its neighbors. Class node contains public integer valuable and public integer val and public list of node type neighbors. For simplicity, each node's value is the same as the node's index, 1 minus index. For example, the first node with val is equal to 1, the second node with val is equal to 2, and so on. The graph is represented in test case using an adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list describes a set of neighbors of a node in the graph. The given node will always be the first node with val equals 1. You must return a copy of a given node as a reference to the clone graph. So example 1. The original graph is here, 1, 2, 3, 4. This is the exact same graph, 1, 2, 3, 4, and I can't return the same graph. So the correct one is the blue one, which is 1, 2, 3, 4. This looks like a clone. The nodes are new. Graph looks the same. So it is the same graph, but it's not. So it looks like the same graph, but it's not the exact same graph. And here is 1, 3, 2, 4. The nodes are cloned, but the graph is messed up, doesn't have the same connections. So input adjacent is 2, 4, 1, 3, 2, 4, 1, 3. The output 2, 4, 1, 3, 2, 4, 1, 3. There are 4 nodes in the graph. Okay, so pretty much we have to return a graph with the same values, but copy it so that it's not the same graph. So you can do this with breadth first search or depth first search, but I'm going to show you how to do a depth first search and a hash map. So let me walk you through the code, through the example. So the first thing we do is we create a map. So let's say map here, and in the map we pretty much store the visited values. And as you can see, the graph that we had was, I think it was 1, 2, 3, 4. So this here is the value, and these are the children within the array. So what we have to do is we create a map where we store the visited objects, and we pretty much do the depth first search to check, start from the current node that we're given, so node 1, and we check with the children. We clone the current node and we put the children, if they've been visited, we set that as the child node. So let me show you as an example. So let's say we're at node 1 right now. So we get the node value, which is 1, and then we create a new node and clone it, and we set that value as the value. So this is the key here, and this is the value, which is a new node. And we set that as in a visited map, so as node 1 with the current node there. So we'll put node here. It's been cloned. Now, there is a child array for that node. So we check the first child and we use recursion on the children. So the first child will be 2. So now we're at node 2. Again, we clone it. So 2 is the key and the node is the value. The new node that is cloned. And we set that as a visited array. So we go 2 node here. Set as a map object, and 2 has now got a child of 3. We again depth first search for that. So we're at 3. We clone 3 as a key, and we set as a value. So now 3 has been cloned with the current node as the value, which is a cloned node. And then 4 is the 3's child. Oh, sorry. 3's child, yep. And so we're at 4, we clone that again, and we set it, the new node, as a value, so 4 node. Now 4 has a child of 1. So now as you can see, the graph is pretty much cloned, but we need to connect all the children. So as 1 is found, we set a child of 4 So the 4's children would be an array of 1, and 3 is found as well as it's in the array 3. So we're done with that recursion there. Then 3, we're at 3 now, which is children of 4 is found. So we set 4. Well, 2 has already been found, so we found 2, and then 4. Now we're at 2. 2 has children of, we already linked 3. We had already linked 1 and 3, so that's done. And moved it up. Now we're at 1, which has children of, we already went to 2. And now we're back at 1, so we go to 4 and link it because 4 is now found. And that's our cloned array. So it'll be 2, 4, which is the children of 1. Then it'll be children of 2 is 1, 2, 2. Children of 3 is 2, 4. And children of 4 is 1, 3. So this will be the return value. So the first thing we do is we create a map. So let map is equal to new map. Then we create a function to depth first search where we pass the root, which is the current node value given. Now, if there is no root, then we return null. Else, if map has the visited node, so if map has root.val, then we return the root.val. Return the root, which will be map.get root.val, because root.val is the key, we need the value. Now we have to clone the root, so we create node is equal to new node root.val, and then we set the value as the new node. So now we have to loop through the children values in the current root and copy them into the children values of the node. So for let neighbors, sorry, again neighbors, not children, I mean neighbors of root.neighbors. Then we get the root, the node, which is the clone root, get the neighbors, and then we push recursively. So we use the current function as recursion, and we push the root, sorry, the neighbor. Next, we return the clone node, and then we return the function, which is DFS. We pass the node. Now let's see if that passes. Okay, that passes. Let's submit. As you can see, was average runtime complexity. This is time complexity of ON as we're looping through the whole graph. Thanks for watching.